Yes. So now we are going to start that we have already started in the previous session, that's control flow. So what I said is so far what you have studied is that there is a flow in the code. So the flow goes from top to bottom. So whatever you write, you cannot repeat things, you cannot go somewhere else. The flow directly goes from here to here. So you just have these lines of code and it will go from here to here. Now what we want to do is you just want to control the flow somehow so that you can do something better. Okay, and these are the building blocks. What have we studied so far? Taking input, output, how what operations are to be done, and I think if you know this, and after that, these functions, probably object-oriented programming, they are just for better design or maybe better coding style. So these are the building blocks. So whatever you studied so far, in that we studied operations, we studied different types of operators, we studied different types of data types. All these things are building blocks. So for any programming language, these are the building blocks. If you know them very well, so this basically means you know more or less every language that is there. Okay, so these are the building blocks. So there are data types, there are these operations that are allowed, and there are different types of these things. After that, after this control flow, probably whatever you will study, so more of them, there will be some sort of having a better style in coding. Okay, and then making code more readable, so that we write the code when we write it, so that it becomes easy for other people who are in the team to read your code and to contribute. Basically these are the building blocks that, and this is probably the last building block that we'll be teaching today. So in the control flow, what we saw is we saw different statements. The first statements we saw were called as branching statements. Okay, so what's branching? So in branching, so we had if, we studied about if, then we studied about if and else, and we studied about if, elif, and else. Okay, and at the end we also studied about nested ifs, or nested, basically nested branching. So I hope that everybody was clear so far with this. Okay, so what I said is the syntax of if is, so if you saw the syntax, I said that the important thing is this condition. So the condition is very important. So this condition should return a boolean. Because we have not recording the previous session, so I'll just cover them in, just give me 5 minutes that we cover everything, and the people who are not in the previous session, they'll get probably some benefit from it, and once they watch the recording, and they'll have clarity what we're going to study. So in the if statement, if you see that we had the syntax was like this, we had if and then we had condition. Okay, and based on this condition, then we had a block of code, we called an if block. Here we had multiple lines of code. So what we said is, we said, let's suppose if you have this if this condition is true, if this condition is true, then what will happen is this code block will get executed. But one necessary point, one important point I'll say is that indentation is necessary. If you do not put indentation, then you will see some problems with the code, and probably sometimes you won't get the syntax error. Let's suppose you wrote if condition it was true, and then you started the statement from here. Let's suppose I'll show it in the code, but here I want to show you, and you did not write these statement. So irrespective of this condition, this statement will be executed now, and be careful for that. When you code in Python, you have to check for the check for this. Okay, if you write this if condition and this colon, now whatever is indented in this, okay, that is the block of the if. That's what if will execute. If you have a line of code right here, okay, that will not be considered as a part of if now. Okay, because the condition you have to indent. That's important in Python. So this was if. So I said in the if, why do we use if? If we sometimes have to, based on this condition, we have to do something or skip. It's not about choice. So here what we have is, you have a condition. If that condition is met, then what you want to do is you want to run these lines of code. You want to run this if block. You want to do something. Or if you want to skip, if that condition is not met, okay, then you want to skip that thing and you want to go further in the code. Okay, and you want to either do it or skip. Okay, I showed you the multiple examples. I'll bring up the VS code so that you have the clarity on that. Let me bring the VS code and just confirm if the screen is visible. So here now the first thing is, I'll copy a block of code just for the syntax purposes. So here you can clearly see that this is the syntax of if. So what you saw here is, so here you saw this if, and then we have a condition, then we had this code to execute. But make sure this indentation should be there, otherwise there will be problems. Okay. So this indentation is necessary. If you do not have this indentation, then there will be a problem. So the example that I showed in the previous session was, let's suppose we have a variable age. So what you want to do is, based on the age, you want to, let's suppose, print if you are eligible to vote or something, let's say. Okay, here if you see the variable is age and age is 25. So now you know that the voting criteria is 18. So for that, what you will do is, so if this age is greater or equal to 18, so you will say you are eligible to vote. So here you will either have to skip a thing or you will have to do a thing. Do or skip. That's what if is used for. And every time if checks for the condition. So now let's just run this file and I'll just save it. And if you now see, so this is test.py. People who are not familiar with the Linux terminal, please don't get scary because I'm writing all of these things and then you see these things on the window. It's basically just a command line thing that you do on the Windows. So here you can see that this statement was executed. So the statement that we had here, so this was 25. Now this condition is evaluated first. So this condition over here was evaluated. So this condition gave us the value true. Okay, after that, if this is true, so then only this will be evaluated. So what I was talking about is the indentation. The important part is indentation. So let's suppose I'll do something like this. I wanted to print you are eligible for the vote, and I want to print one more statement. Print. Now you are an adult. Let's suppose now you are an adult according to democracy. Okay, this is what I wrote. So now you can see this. So this print statement, it does not belong to the second print statement that I wrote. It does not belong to the if. Okay, so irrespective of the condition, so this will be still executed every time. Okay, let's now just ascertain what we have said. So if I run this Python, you can see that you are eligible for the vote, and now you are an adult according to democracy. So what I'll do is, let's suppose I'll forcefully make this condition false. I'll say 15. Now you know that this condition will be, if you have this statement, okay, this condition, so it will give us the false, and after that this statement should not get executed, but this will anyway get executed because it's not part of if. So many times I have seen people who start with Python, they get problems over here. So sometimes they don't indent properly, and then after that they'll see the result which is not indented. So let's suppose we'll run this file. So you can see now this statement was not executed, but anyway this statement was executed. Why? Because it's not part of if. Okay, be careful in that when you're coding. See where you have indented the files, where you have indented these lines of code. Okay, the main thing that you have to remember for this if, the only one important point is that if you want to do something or you want to skip something, okay, and then you want to use if. So I can give physical examples. Let's suppose either you want to go for the play or you want to skip that. So you will see the weather. Let's suppose you see that if the temperature is greater than 25 degrees, then only I'll go out. Otherwise I'll skip. I'll go to the next line of the code. Okay, that's the part of the if. That's the job the if. If sees if you have to do a job or you have to skip it. This is the thing about if. Now let's move to if and else. Yes. So the second important branching statement was if else. So in this the important thing was you have a choice now. You want to do one thing or the other. Okay. So you want to do either one or the other. Let's suppose if I am saying if I have a number, I have a number, let's suppose 15, and I want to see if this is my number 15. I want to check if this number is greater than or less than, let's suppose, number 50. Now I have two choices. It can be either less than or it can be either greater than. Okay, now two choices are there. I gave a very simple example, but I think that this gets the point through. So if you have two choices, you want to do something based on the condition, and now these two things are mutually exclusive. By that I mean that only one of the code block will get executed. It's not that if and else both of them will get executed. So the syntax will be something like if you have this if, and then you have a condition, okay, and then you will write the block of if block. So this will be if block. Then we have this else block. Okay, and then we have this else block over here. So this is the indentation, how this will look like. This is the syntax. Sorry, this is the syntax. So syntax of if else is like this. So else should be preceded by if always. You cannot write else alone. So you'll get a syntax error there. If you try to do so, so you will have the syntax error. So what you have to do is you'll write if a statement. So now based on this statement, either this will get executed or this will get executed. So what I'm saying is that let's suppose this is true. If the condition is true, this tells me that this if the block under if will get executed. Or if this condition is false, so true, it can be true or false. Okay, so either this will get executed Based on false, this will get executed. So you might have seen also flow charts, something like this. So there is a program running. So there are multiple lines of code that has been written, and some now you'll see a condition. This is how I'll write if. Okay. So this is the condition if. So if the condition is true, so something will happen. So this is basically true, and if the condition is false, some other thing will happen. Now you see this if and else. So this is the part of if. Let's suppose. So now this is if block. This is if block, and this over here will be else block. Okay, so this is the flow chart that people use to keep the track of the code. When your code base is really huge, I'll probably will use some of these flow charts. When your code base becomes huge, you'll have to make these charts, which function calls what and what are the conditions, what is the flow of the code, because you cannot keep the whole track in the head. So probably many of you might have not used such charts in the coding, but it becomes really important when you write a huge code base. There you must know, okay, this is the structure of the code. You have a particular directory structure where you write the code in multiple files. So to know these flow charts, to know how to draw these files and which function calls what and what is in the function, you just write these things so that you have the clear sort of idea about the whole structure of the code. Okay, so what I said in this if is that you will check for the condition, and based on that condition you will either run if block or an else block. Okay, this is called as if else statement. So we are under that branching statement. Do not lose that vision. So I said you these are building blocks. The first building blocks was the data types, operations, how to perform these operations on multiple different types of data. Now we are seeing that now we want additional control. So okay, the flow, the control, the code was from top to bottom. So you'll just run through the line. But I want additional power. I sometimes want to branch out. Okay, I sometimes want to go back, or maybe I have to execute some other statement. I don't want to repeat this code. Okay, I don't want to say, let's suppose if you don't have branching, then you'll have to come up with these go to statements which were there in the earlier languages. Okay, now again going back to the code to show how this if and else works. Okay, and let's suppose I'll have the syntax first, and after that okay, so this is the syntax. So if you see, you have a if here, and you see that you have if here, and then this condition. I wrote this code to execute if condition is true. If this condition is true, then this code will execute. And now be careful again, indentation is really important. Now else block, this will be executed if this condition is false. So now I said one important thing is, so for this I'll write, so this is like mutually exclusive. So what I'm saying is mutually exclusive. If this runs, this won't run. Okay, or if this runs, this won't run. If block is executed, else won't be executed, or if else is executed, if won't be executed. There's only one will be executed. So one more thing that you have to know, the second thing that you have to know is, here we have one thing or the other, one or other. So in the if statement we have do or skip. You have to do one thing or skip that thing. So here you have to either do one thing or the other thing. Okay, that's the difference between if and else. Okay, but be careful with because people sometimes use multiple ifs instead of if else. So now you know clearly that if you have this if else, only one of the statements will get executed. Let's take a concrete example. Let's suppose I want to check if a number is greater than 5 or less than 5. So what I'll do is I'll just write a line of code over here, maybe multiple lines of code. I have commented this out. Let's okay, so here I have first given a variable x is equal 3. So if I just show you, so this is the picture that should be formed in your head. So when I write x is equal 3, how you should write this code, how you should read this code basically from the head. Proof, we call that dry run. So how you should dry run the code. Okay, how do you should dry run? So you'll say x is equal 3. You will make 3. Okay, because I'll come from right. I'll come from right to left once I am evaluating the expressions. So I'll see this 3. This object gets created in the computer's memory, and then I'll bind this to x is equal 3. Let's suppose this is my computer's memory, something like this. So then I'm saying x is greater than 5. So I'm checking the condition. I'm saying if this x is greater than 5. So this statement over here, okay, this will give me false. Now you know that if this is false, if block won't get executed. Then we'll directly come to the else block, and this else will get executed. Okay. So now let's just confirm it once. If this is true, so I'll just run the same file. First, before running, I'll just save the file so that you can see that this x is not greater than 5. So this else block got executed. Okay, so this is what if and else does. So if is that when you want to do something or skip something, if and else is therefore when you have to do one thing or the other. I hope this is clear. Okay, let me pause here for a second so that if you have questions, you can take them. So now we'll see nesting. So what is the meaning of nesting? So this is a generic term. It doesn't only apply to branching, it's a generic term. So what this nesting is basically if you write one thing inside the other. Okay, So we have also went through the functions in the mathematics. Okay, so if you have a function inside, we have a function. You have that function within a function, something like this. This is some sort of nesting. Okay, you first evaluate a thing, then you evaluate one thing, and you evaluate outer thing. So we have a concept of inner and outer here. So here if you see over here, this is inner function, and this is our outer function. Okay, so you're nesting these functions. You're having a function within a function. Okay, so here you are having, I'll call it a hybrid nesting. So basically you have one function and you have other function. So if you want to have simple nesting, you'll have probably one thing, and within that you'll have the same thing. Okay, so this is the concept is generic. This does not only apply to this nesting of ifs. We'll have nesting of loops also. We'll have nesting of functions also. Okay, so nesting means one thing within the other. So if I just write in the simple things, so this is one thing within the other. So the first thing that we can see is nested ifs. So I said one thing within the other. If I say nested if, that means if within other ifs. So here if you see, I'll write if, then I'll write a condition. Okay, and then I'll have to execute some things. Okay, so within this if, I'll write if. Say this is my second if, then I'll write this condition 2, C2. Okay, so within that I'll write this. So now if I tell you, for the first if, this whole is the block that will be executed based on this condition. Okay, so I'll call this outer if. So this is my outer if, and over here this is my inner if. Now inner if, we have, this is the code block that belongs to this condition 2. This is my condition 2. So now if the condition 1, or I'll call it condition only, so this condition is true. So what will happen is, it will try to run whole of this block. So it will execute this, and then it will execute this also. Now based on this condition 2, we have to make a decision, should we execute this or not. Okay, so if this condition is true, then only this will get executed. Now I told you one important thing, that was, so if this is not there, let's suppose this is not there, if you are writing if within an if, and in that you don't have these 3 lines of code. Okay, so what you can do is you can just use the logical AND operator. So if you have if, then you have condition 1. Okay, then you have another if, you have condition 2. I said this is equivalent to logical AND operation. Okay, just let me go to the coding window so that we can just practice what I preached. So now first thing is, I'll show you the syntax. So syntax looks something like this. So this is the syntax. Let's just clean this code up. So if you see, here we have the if, then we have this condition 1. Then I'm saying code to execute if the condition 1 is true. Whole of this will get executed basically. But now we have this condition 2. So if this is true, then only this will get executed. Okay, so this is the syntax of this. I hope that this is clear for you. Now I'll just see if a number is between 5 and 15. I think this example I have shown in the previous session also. I'll just repeat the example. So here if you see this, comment out the code. Now you see this variable x is equal 10. Again, let's make a picture. So this should be now spontaneous for you people. So when you read this sort of code, so x is equal 10, you will make the memory like this. So 10 will go from right towards the left, and now we'll have to make an assignment. This is x is equal 10. So this is called as binding, variable binding. Now we'll say if x is equal 5. And the first condition that you saw, this is true. The first condition is true. This condition is true. Now what will happen is, we'll come to second condition. So if x is less than 15. Okay. So what will happen here is, so if this condition is true, then only this will get executed. Otherwise it won't get executed. That's the reason I said that if there are 2 ifs consecutively and there is no statement in between, so this is equivalent to having an AND operation. Okay. You can say if x is greater than 5 and if x is less than 15. This will have an equivalent effect as this code has here. Okay. Let's run this and we'll see. Okay, running this code, should make sure that you save the code first. And if I run this test, and you can see the x is between 5 and 15. So if I just write it, let's suppose 16, so nothing should be executed. So I'll say end of nesting if. I'll just make sure that you see that nothing gets printed after that. So this is end of nested if. Okay. So now if I run this code, you can clearly see nothing got printed except this end of nested ifs. Okay. So what is the equivalent of this? So the equivalent of this, I can write this code probably in by using the AND, by using this AND operation, logical AND, because you can clearly see this is logical AND. But one condition there is that there should be no statement within that ifs. Like when you write first if, you should not write any other statements. You should directly write this and that if. So let's suppose we'll write if x is greater than 5, and now we have this AND operation, and x is less than 15. So if these two conditions are met, so now what I have done is I have used logical operators in between. So print whatever this is, number is greater than, number is between 5 and 15. Okay, so you can see that this is also, that's the beauty in these code editors. You can see that x got somehow this warning sign that says that x is not defined. So I'll define x over here. So x is equal, let's suppose 10, something like this. So here now if I execute this code, you will see that whatever effect the previous code had, so this will have the same effect. You can see the number is between 5 and 15. Okay, but where it gets different is, let's suppose this code was not like this. So previous code that we had, it was not like this. So within this statement we had something. Let's suppose this is the code, I'll uncomment it. So within this we had some statements execute. We had, let's suppose, print x is greater than 5. X is greater than 5. Okay. So now we cannot write AND statements, because here if you see this, we now in the first if we somehow injected these more statements. We did not write the second if directly. So now we will not use the AND operation over here. So but here also you can concatenate over here also. So what you can do is, so you can do some things in the expressions and make it print like this. But if you have these multiple ifs, so otherwise this code becomes clumsy. So if this is if there are statements in between, try to write these if within the if. Try to write nesting ifs. If you but if you see that we have if that is directly followed by another if, try to write the AND operation in between. Okay, just run this code to see the effect. So you can see that x is greater than 5, and then it skipped the other because x is not. So the second statement, so the condition second did not get executed. So here x, this is true, so that's why this got executed. Okay, this line got executed. Then we have the second if. So if x is less than 5, so this was false, so this was not executed, so this was skipped. So now here we had this end of, this is anyway printed because this is in the normal flow, this is not in the branching. I hope that this is clear. So this was our nesting of this if, and we can have nesting of this if and else also. You can have if, within that you can have if else, and within that internal if you can have if else. But what I said is, one important point is that you'll have to keep track of these else. Okay, home if it belongs to. I said that this else is always preceded by if. So there is if first and then there is else. Okay, so I'll just write it in the pad without this VS code. It's clear. So I said if we have if and if you have this else. So else is always preceded by this if. So if there is only else, we'll get a syntax error. But now when you're doing this nesting, when you're writing if within that something else, so you'll have to keep track of this else. Which else does this if if does this else belong to? You'll have to see कि ये जो else है where it belongs to. You can see it here over here. So what you can see is, let's suppose this is condition 1. So I told you that in these modern editors you will get line like this now. Okay, so as to keep a track. So we want to make sure that this else belongs to this if. Okay, you'll write condition, and then within that, let's suppose you have end the if. Now you have end the if, and you have condition 2. Okay, now you have else for this if. So if you write else, so here the line will be dropped like this. Okay, so make sure that you do not mess with the code, because when you write the huge code base, so that you'll use this nesting of these if else operations, or if else rather I'll say these control flow statements, branching. So make sure that you don't have this else dangling here and there. So you sometimes you'll feel that this else should be the part of this if, but somehow you just indented it wrongly, so it becomes the part of the other if. Okay, and you know that if can also work without else. Okay, but else cannot work without if, because for else to execute, the condition of if should be evaluated first. Okay, you make sure of this. Okay, this is what I can say warning sign. So I'll just write triple stars over here. When you write the huge code, and if you people are writing that, you will feel this is the problem that many of the people find, that okay, what is this else belonging to? Okay, even sometimes compiler has to also do this. Okay, that's why if there are these brackets are necessary or the indentation necessary, probably we'll go into the internal details. Sometimes you can also confuse compilers. Okay, and that's why these compilers you have to write else in such a way so it is not confused that this else is not there with any if. Okay, so this is important. Just let me show that. Okay, I just wanted to show that in the VS Code, that coloring part. I think I showed that in the previous session also. I just want to make sure that everybody knows that. Okay, now showing it there. So you can see this line over here. If you see this line over here, so this is the line. Okay, so let's suppose I'll write else for this if. So if I write else over here, okay, else, let's suppose print high, something like this. And now if I want to write else over here, so else print hello, if you can see it over here. So this is the first if, and so this else belongs to this if. So you can see the clear line over here. Okay, I have seen people who do not use these editors, but it makes the job easy because some people like it the hard way. Okay, but I myself use the editors now, and probably when people start coding, I think in my era there were no such editors. The first editor that I used was Turbo C++, and it was horrible. So here now you can see that there are a lot of things have been done in these editors. Okay, so they are called as interior development environment. So here you have everything over here. You have compilers, you have these color coding schemes, and for every language you have this now. So you see this if, and this if has this else. So this else belongs to this if because you see a straight line from here to here. Then this else belongs to this if because you can see a straight line from here to here. Okay, I hope this is clear. Let's move ahead. Okay, now what is done? So we're done with if, we're done with if and else. So now what we'll see is there is something called as if, elif, else later. That's the name given to it. Okay, we have if and we have elif and we have else. Now you saw that if we have if statement. So what is the job of if? If you want to do something or you want to skip something. So then we had if else. If you now have two choices, you have to do one thing or the other thing. Now you know that in day-to-day life we sometimes have multiple choices. Okay, for that we need to do this. Okay, for multiple choices we need to use this if and elif. Okay, so this again is all again mutually exclusive. What I mean by mutually exclusive, only one of them will run. So I'll write if condition 1. If this is true, let's suppose this should be done. Okay, this block of the if. Elif. If this condition is not true, and I have a second condition to check. Okay, I'll see condition 2. Then this will be done. So you can only stop it over here. There is no need for else. Okay, but else is that if you do not want to check for the condition. Okay, if you just write else for this, so what will happen is if this condition is not true, then only else block will get executed. Okay, otherwise what will happen is one of these blocks will execute. Whichever condition is true, that block will get executed. And you can have this later of the things. You can have if, elif, and at the last else, or you can you can choose not to use the else at all. Okay, so this is called as if, elif, else later. So you want to check for the multiple conditions here. You have multiple conditions, and based on that you want to take a decision. So the typical example that I showed you was if you want to grade something. So let's suppose you are in the college, university, and you want to build a software like that. So here there you will give probably A grade, B grade, C grade, D grade, probably F grade, something like this. And you know that I have to check different conditions. Okay, one thing is that you can achieve this by using the F. Okay, so but you know that only a person will get only one grade. Person will not get A, B, C, D, F grade. Okay, out of these grades, person will only get one grade. That's what I'm focusing on, this mutually exclusivity. So that these things are mutually exclusive. If out of these conditions only one thing, if one thing is true, and then we want to execute it, we don't want to care about the conditions then. So that's why this is used. Okay, and I'll again write it. Only one block will get executed. So am I stressing so much on this? Because you can achieve the same things by using if. But what will happen in the if, that if condition, if when you use the syntax of if, it will check for every condition. If you write if C1, if C2, if C3, let's suppose here you wrote if and then elif, then else, let's suppose. Here say we have the C1 is true. If the C1 is true, it won't go to this elif. It won't check for the condition at all. Okay, but if you write this if you write if first and then you write if just got executed, still it will go and check for the other condition. Okay, that is the difference between if, elif, if and else. So here, if you want, if you have a requirement such that only one thing gets executed out of all these options, so then the best thing is that you can use this later. The typical example I showed you is the grading. Let's suppose you want you are having the marks of the students and you want to grade them based on the marks they got. Okay, let's see that. I hope that syntax is clear for you. So syntax is like this. So if you see syntax over here, so syntax is like this. Let me show you over here. So this is if and this is condition 1. This is the code to execute if the condition 1 is true. Then you have elif. Now you have second condition. Okay. Now if code to execute if this condition is true. If both of them are false, then only else will execute. And you can have a letter of these things also. Okay. Now we'll see that grading. Suppose you are probably a professor or a teacher in the school and you want to grade students based on the grades they got, based on the marks they got. So here if you see this, I'll just paste some lines of code. So now you can see here score is 75. This is the variable that holds the score of a student. So the first condition is if grade is greater than 90, we'll give them a grade. If this marks is greater than 90 or score is greater than 90. Otherwise, you know that if it's below than that, it's greater than 80. So this condition over here, let's suppose when will this get executed? So if you focus over here, so when will this line execute? If the marks are between 80 to 90 or 80 to 100, I'll say, for example, if we have 80 to 90, but marks should be greater or equal to 80, so greater or equal to 80 but less than 90, so then only this statement will be executed. So between this 80 to 90 range, so this statement B grade will be given. So let's make this table over here so that it's clear. So if the marks is between, let's suppose, 90 to 100, so I'll not write it here, I'll write it here. So if marks is between 90 to 100, this is inclusive, I'll write it like this, 100 inclusive, so we'll give it an A grade. Okay, if the marks is between inclusive 80 and 90 is not inclusive, okay, we'll give them B grade. Okay, then we have, if the marks is between inclusive 70 to 80, exclude 80, and we give them the C grade, and otherwise we give them the D grade. So whatever is less than 70, whatever is from, let's suppose, 0, or whatever negative from minus infinity to, let's say, 70, but 70 is exclusive, we'll give them D grade. Okay, this is our scheme. This is how a professor decides to give the grades. Now you see this is the range. Okay, and you know that a student will only get 1 grade based on the score. So that's why you write it here. If you, let's suppose, want to implement the same program in if, so what you will say, you'll write if mark if score, let's suppose S score, so I'll write it here. So if score is greater than 90 and score is less than 100 or less than 100 equal to 100, then A grade. Okay, then you will again write if, and you will check for multiple ifs. You can use multiple ifs to achieve the same thing. But see the magic of this if and else, because you know that your specification is like this. Your specification is that the only one condition will be true, and if the condition is true, and you just want to assign the grade, you don't want to check for the multiple conditions. Okay, if this is the requirement, you should use this if else. So let's run the code and we'll see what will happen. Before it, make sure that you save the code. So how I know that the code has not been saved? How I know this? Let's suppose I'll show you that also in the VS Code. So here, if I write something, so now if you check on the top of this test py, you see a dot over here. So this tells me you have unsaved change. You haven't changed something. You have changed something, but you have not saved it. Let's suppose if I press Control S, this vanished. So this dot is nowhere here now. Okay. So if I again made some change, now again this dot appeared. Okay. So now I'll just make some change. I made the change, and here you saw this dot. So this is how I ensure that I have saved the program. Now I'll run this again. So you see that he got the C grade. Okay, because marks is between 80, the thing that we have on the screen. If you see, this is the thing that we had. So why he got C grade? Because this is C grade. He has marks are between 70 and 80. Is it clear so far? Why do we use this if, elif, else later? Is it clear? Sometimes I have used people using this multiple ifs. If marks is between this and that, if marks is between this and that, then do this. So it's better to use this if, elif, else later. So this concludes our branching statement. So there may be some points to talk about, but if you know this stuff, whatever we have been speaking since last half an hour, so this completes the branching. So we have control flow statement. So in the control flow statement, I said the first part is branching. The first part is branching. Okay, in branching, what we studied is the 3 important concepts we studied. We studied if, we studied if else, we studied if, elif, and else. And for all these concepts, we also studied nesting. Okay, so these are the 3 things that you should know: if else, if, elif, else. Okay, these are the branching statements, and the job is, if you have a flow, the code is top to bottom, line by line. So, but you want to deviate somewhere. Okay, you have flow of code like this, but based on a condition, you either want to go here or you want to go here, or maybe you have multiple conditions. Okay, based on those conditions, you want to take a decision. That's what but is achieved by the branching statements. That these are called as control flow statements. Everybody with me so far? Okay, now let's go to the under control flow statements. Control flow statements. So these are called as iterations. Okay, remember the fact that I'm not teaching you programming, rather I'm teaching you art of programming. All of these building blocks are applicable in every language that you have. Okay, I have a terrible handwriting. Sometimes I realize that once I write in the board and I read it myself. So what I'm saying is that we are so far reading the building blocks. After that, what are functions there are? Let's suppose we have this object-oriented programming. That's just a code, styling the code, so that you write the better code. Okay, and all these are building blocks, and most of the languages have these building blocks. Okay, now another building block that we are studying is control flow. In this, we studied branching. So branching done. Now we are in this iterations. So the joy iterations, if you want to do something over and over again, okay, and you want to do something many of the times, you want to check for a thing and you want to do again the same thing, you want to do something, you want to iterate. Basically, what does the meaning of iteration? Iteration means you want to go through over it again and again, okay. So that's the meaning of the iteration. So sometimes in programming you won't write it. Let's suppose you can write it like this also. So you have to do something, you have to print, let's suppose some hello 5 times. So you can write print hello 5 times, you can write print hello again, that the same statement 5 times. So you can see how lazy I become over here. I cannot write the 5 statements, I just wrote the dot dot dot. But that's what the programmers thought. They thought, okay, without loops we can achieve many things. But the thing is, code becomes too much clumsy now. It becomes, we have to write a lot of code. So now you can see that we are repeating these lines. So why to write these lines? Why not to have a loop sort of thing? Why not to have some iterations? We loop. That's what. Why is it called loop? Because it goes through like this. It's a cyclic thing. Till a condition is met. Till, let's suppose we want to have it 5 times, and that's what we have. So if we start, there are different loops in Python. So the first loop that we have is called as for loop. It is the first loop that we have. Okay, Python syntax is a bit peculiar. So just key folks, if people have not coded in Python, if they have from C or C++ or C, so because the syntax is different in Python. Okay, so again the language philosophy is ease of programming. This has been made easy for the programmers. So if you see the core syntax in C or C++, you'll probably write for, let's suppose, then I is equal to something 0, then I is less than 15, then I plus plus, something like this. Okay, and we call this loop initialization. This is the loop condition. This is the loop increment or stopping condition, we can call it. This is the stopping condition, and we can call this as increment or decrement, whatever you say. You can write any expression over here. This is not necessary that in C you will write initialize in I is equal to 0. You can do something else over there. Okay, but in Python we have a peculiar syntax. So what is the Python's for loop? So if you have sequential thing, you have to do something sequentially. Let's suppose you want to travel over something, you want to traverse over something. Okay, now you know that this is my, let's suppose, a list of elements. We have 1 2 3 4 5. We have seen what lists are. We have not seen them in detail though. We will separately take a class in data types of Python. So here if you see this, by data types I mean I'll show you every function that's there. So 1 2 3 4 5 is there. I want to print all the things that are here. So you know that this is randomly accessible. I can print this, then this, then this. Now you know the code will be similar. So I just have to see the indexing. So that's what I will use these for loops for. Okay. So for loops in Python, they're used for sequential traversal. Okay. And this whatever traversal there is, because you know everything is an object. So this should be actually an iterable. Okay, this should be an iterable. So now we'll see the difference between what is an iterable and what is an iteration, or what is an iterator. Okay, so iterator means whoever is iterating, and iterable is the object under the consideration. Okay, here if you see, this is an iterable, and if you write, let's suppose for Python, this is, let's suppose we'll call this a list A. So this A is now iterable. So okay, so iterator will be some variable I. So this I can be called as an iterable. This can be called as iterator rather. This is iterator because it will just index, it's using an index variable and will go at each place. But this should be iterable. Okay, iterable basically means you should traverse it. That should be a construct traversal. If I give you some object, let's suppose a function is also an object. Okay, if a function is an object, if I say I have a loop and for in that loop I'll say some integer is 5. So can I use loops over here? No, I cannot, because for loops I have to traverse, and for traversal the thing should be iterable. Iterable means I should have an iterator which can go location by location. So how is this for loop used? What is the syntax? So we'll use for, the syntax, the for, and then we'll use this variable. Okay, for variable, then we'll use in, this is iterable. Okay, and this is my iterator, okay, iterator variable, and this is the iterable. Okay, then I want to do something over here. I can write statements over here. One, let's suppose I'll create a list. So you know how to create a list in Python. I'll say, let's suppose I have a list li. This is my list. I have multiple elements. Now I want to print these lists one by one. So again, you saw this in again is an operator in Python. This in is an operator. It goes and takes the value. Okay, li is equal. Then I can say I'll give it. This is my list, and I can use this for loop. Let's better to go to the coding window to explain these things. We can iterate to the list because list is an iterable. Removing all of these things, and now I just clean this also. So this is the syntax of this. So first thing is we'll use for loop syntax for the list. So in that you have these variable statements. So I'll just write the syntax over here. So this is the syntax. So now if you see this, the syntax is we have this for, we have this variable, and we have this iterable. Now we have two things here if you see. The first thing is we have a variable, and then we have this iterable. So what is this variable? So this variable basically takes the value of each item that's in the iterable. So whatever this iterable is, this iterable can be a list, it can be a tuple, it can be a dictionary, whatever, it can be iterated. So this is the iteration over here. So this iterable can be a list. I'll just take an example of list, maybe 1 comma 2 comma 3 comma 4 comma 5. This is the list. So this variable will take the value of these things. So if I say for variable in, okay, iterable, so this variable basically will take in the first iteration, rather, it will take this value 1. The second iteration, it will take this value 2, till we find the end over here. Okay, and Python will have implemented somehow. It will check the end. If the list is, it will continuously check if the list is empty. If the list is empty, then only it'll check this, because I said that there should be a stopping condition for the loops. Okay, if you have this loop, you have a variable. So variable it takes the value of each item in an iterable, but one at a time. It's not taking all the things at a time. It is taking one at a time. Okay, and then we have to do something with those variables, or whatever the values are there, and then this is the iterable. The iterable is basically, it's a collection of objects we have, like, so it can be list, it can be a string, dictionaries. Okay, and we are here seeing it for the lists first. Let's see it for the list first. Let's suppose I'll write some list. Let's suppose I'll define a list, call it L. Okay, so I'll say these are the students that we have here. We have Mahmoud. Okay, and then probably we have let's suppose Anwar, and then I'll just, you can again see that I missed the quotes. So what I'll do is I'll select all of this, and then I'll put invert quotes. Now you saw that both of these got this and enclosed in the quotes. That's why these are the shortcuts which you'll use in the VS Code. Okay, and I want to again write some other student, maybe Arshan. Okay, this is the list. Now you know the list, it contains different objects. So objects here are strings. So you have Mahmoud, you have Anwar, you have Arshan. Now if I want to print all of these, okay, what I can do is I want to print them one by one. Okay, I want to greet them. I want to say hello Mahmoud, hello Anwar. So what I'll do is I'll write for iterable. I'll write a name, for name in L. Okay, so this name now is a variable. So if you see this name is a variable, and this L is basically iterable. Now be careful about the syntax. So again, I'll put this quote. Sometimes you might see that people are putting semicolons, and that is a terrible mistake sometimes. Okay, semicolon in Python means termination. Here, make sure that you only put this code. Now you say I want to greet all of these people. I'll say print. Now comes this f strings in the picture. I'll say f, and then I'll say hello, comma, and then I'll write this braces. I'll write the name. This name is the variable. Okay, if I just save this program, and if I want to run it, I want to greet everybody. So here python test.py, so you can see that hello Mahmoud, hello Anwar, hello Arshan. Okay, because now you see this, we wanted to greet everybody, and the code was similar, and we use the iterations. Okay, and this thing is an iterable. So this list over here, it must be an iterable. So this thing over here must be an iterable. You can do the same thing, let's suppose, with tuples, or maybe with other iterables. So where we have a concept of traversing. Okay, if you have a dictionary, let's suppose, if I want to create dictionary, so let's write that code also. Maybe I'll comment this out. If I want to comment this out, I'll just press Control and \. That's how it gets commented. Note these shortcuts, so it will really help you once you're coding. So here, if you see this, I have created dictionary. Okay, so far probably you don't know the syntax, and you will slowly get accustomed to this. So here, if you see this dictionary, D is created, and in a dictionary, you know that we have this key and values. So dictionary basically means where you have the concept of key and values. So here, if you see, the key is this XYZ, and then we have a dictionary like this. So we have dictionary. In this, we have key value pairs. The first is XYZ, and then with 1, 2, 3. This is my key, and this is my value. Okay, and then I have ABC, and then we have 3, 4, 5. Okay, this is my key, and this is my value. It's like the dictionary. If you want to search for a word in the dictionary, English dictionary, and you have English to Hindi dictionary, or maybe English to Urdu dictionary, you will just search for the word, and then you will find a meaning associated with that, and you have a key, and you have a value associated with that. Okay, that's what dictionary is. Again, the dictionary is iterable. So if you see the dictionary is iterable, you can iterate what is. So here I'll use this variable I. Okay, this is my variable. This is my basically iterator. It will take values one by one, and then this is the D. Okay, so now if I want to print that, if I just want to run this code, you can see that first the XYZ got printed, because this is I. I is, it takes the value, this key, and D of I basically means give me the value which is in there. Okay, dictionary is like this. So if you want to have a map of, so this is something like this. Okay, this is my I, or maybe key, and this is my value. So key here was XYZ and ABC. So the value in that key, value corresponding to this, was something like 1, 2, 3 and 3, 4, 5. Okay. So when I say key, so key over here will be stored in this variable. So for I and D, it will just take the key. It will take this element over here. It will take this element X, Y, Z, and ABC. Now what I am saying is, I'll say D of I. Take whole the dictionary, whatever the dictionary, and take the ith variable. Okay, and then it will give me this 1, 2, 3, and then 3, 4, 5. That's what you saw on the screen. X, Y, Z, 1, 2, 3, ABC, 3, 4, 5. So again, you can use it in dictionaries. You can also use it over strings. So you saw how to use it in the list, how you see how to use in the dictionaries. So you can also iterate it, because again you know that the string, it is again iterable. There is a concept, you can traverse the string. Okay, so here if you see this, so I'll just comment it out. So I'll just make sure that I'll write, this is for loop for dictionaries. Okay, too lazy for type, I'll just, and then I'll write here for loop for lists. I'll probably show you one more shortcut. Let's suppose you wrote something and it's wrong, and you want to clear the whole word, not one by one. You can just press Control \. So whole of the word will get erased. So if I'm writing, let's suppose there, and I mistyped something, I want to erase all the things and I want to rewrite it from the scratch. So I'll just press Control and \. I hope that these shortcuts will help once you like start coding. So now we are saying, I'll say iteration or iterating, or yeah, for loop for the strings. Again, I'll press Control \. to comment out this, and let's see it over the strings now. So let's suppose I'll create a string. I'll again create a string that's called S. I'll create it. So who we missed? So I'll see your names. Let me see your names. So we have Ali over here. So I'll write Ali. So now I want to iterate over this. So I can say for letter in S, print this letter. Let's have print S. Okay, so can somebody tell me what should get printed on the screen? Exact print. If you can write the comment so that I can see it. What should appear on the screen? Because how to think about this Ali? So Ali is a string like this. So this is, let's suppose A, this is L, and this is I, and then we have some constant null space, null character, which says this is the end of the string. So what should get printed? I want to see your responses. Pretty easy. This should be pretty easy, I hope. Yes. So this is A, L, yes. You guys know how the print statement worked. Okay. So what will get printed is A, L, and I. This is how it will get printed. It will get printed one line after the other. Okay. This is how it will get printed. First A will be printed, then L, then I. Because if you see this print, if you see the documentation of the print, so print the documentation is there is something called as end. So end by default is \n, the null character. Okay. Let me just print it first, and then I'll show you. Then we'll bring in the documentation also, so that you also learn how to use documentation. So we'll run this first. So I want to just ensure this. So you have printed. So this is, oh, this should be rather S of letter. Have I done some mistake? So for letter in S, so print S. So rather, what is it printing? Tell me why. Tell me why is it doing so? Is there a syntax mistake?
You should have printed letter instead of S.
Yes. This is my mistake over here. So that would debug the code like this. This is the letter. Because letter is my variable where I keep these things. And one more thing I'll tell you here is, so what you have to do is, you have to make sure that you debug the code. Let's say you write something, you try to run it and see the output. Otherwise, if you run a huge code base and then you run it and you don't know where the error is. So if you make slight change, make sure that you check it accordingly. Let's say we wrote this loop and I by mistake typed S in the print statement rather than letter. Okay, I got this Ali. Okay, I should have rather printed this letter. So it's a best practice whenever you write small snippet of code, try to run it first. Okay, and then basically debugging becomes easy. Okay, that's one thing for the debugging. Okay, let's now check for the documentation of the print statement. So here now, if you see, if I just want to search for the documentation of this print statement, so print Python maybe documentation. Here you have this Python docs. So I'll have to check for print if it is there somewhere. Yes, it is here. So I'll just click on it. So here now you can see this. I'll just increase the size again. Okay, just make sure that this is visible. So here if you can see, this is print. Okay, and this is object, this is separator, and file none and flush false. So there are a lot of these arguments. Okay, so this is the documentation. So this is telling me, okay, give me some objects, and then there is a separator. What should I separate it with? If I have so here if I have multiple objects, I should separate them with a space. Then by default, if you see, this is \n over there, and you can overwrite it. Okay, if you saw the doc, and then you have this file none. If you read the whole documentation, you will get to know what these things mean. And this flush, if you want to flush this, okay, if you want to delete it because it's stored in the buffer, okay, that's what by default is false. So false means it'll store in the buffer. If you want to flush it, you print it, you want to flush it, and you can keep it true. But this is documentation. But on what we have used, we just use print and then object, and all these things, and these are the parameters, and they have the default values also. That's why we didn't write that. We just gave this. If I write print without even something, so what is this? So even if you see this object, so it should not print anything basically. So these arguments are optional. So we learn this in the functions. Okay, but what I want you to show is this end character over here. So end is \n. That's the reason we saw when the elif was printed. You first got a, then this basically takes the cursor to the next line. Then L was printed. Again, it took the cursor to the next line. Then I was printed, and that's the job of the end. If you want to override this end, you can maybe just separate out with space or nothing. So let's close this Chrome and again go to the VS Code. So now I want to print, let's suppose LE, not just A in the first line, L in the second line, I in the third line. I want to just print in the single line. So what I can do is I have to make change in the code. So what I can do is in the print statement itself. So you saw that is that end parameter. End is equal to, what we can do is you can just put nothing. Okay, you're overwriting this. So now if you run it, you can see that Ali got printed. Is it clear now? This is how you check the documentation, and then you should read about these things. Okay, what does this end mean? What are the arguments that it takes? So even VS Code shows it. If you just type, I had this print over here. So if I hover the cursor over here, so I just will replace. Let's suppose I just wrote end. You can see en. So it shows me this is the function. This is it takes. It takes this end as an argument, because this VS Code searches for the Python, because Python package is installed somewhere in your computer. So what it does is it takes that print statement and checks what are the arguments that it takes. Okay, that's why it gave me the first suggestion as end. Okay, and also if I let's suppose say separator, because that is the SCP, you can see that SCP is the second argument over here. This is the second line basically. So what these are beautiful things that VS Code does, or maybe other editors also does this, PyCharm or things like that. So they give you the suggestion, so it becomes easy for code. So I will just like press this and press the tab, it will complete it. Okay, I don't need to type the whole thing. So I'll just press S, and then I'll press this bottom arrow, and I'll press the tab button. Okay, sometimes these argument line they are very high in length. So let's suppose you don't want to type all the things. You can just see the suggestions and maybe click on that, or just maybe hover the mouse over there and click on that. This is what I wanted to show you, how to read the documentation. Just a detour, or maybe a digression. Again, this LE, it was a string, and we here what we use is we use this for loop, and this string again is an iterable. Okay. I hope that iterable you got the clarity of iterables. You should have iterable, then you have a variable. That variable takes one element of the iterable at a time as the value, and then you can manipulate it anyway. Okay, so that's what you can do. I'll just comment out this code also. This is one type of for loop where the syntax was you have this for, then you have variable, then you have iterable. Now what you want to do is you sometimes want to repeat some things over and over again that you are accustomed in by using in C. In C you basically use some indexing variable, then you give it a certain value. But this is the thing that basically this is how for loop works in Python. So now we'll have to also achieve that thing that we achieved in C or C++. So you should remember the syntax. So now what we have to do is, I'll just also keep this Chrome off, keep this VS Code off. So again the syntax will remain same. So now what I'm saying is, if I have to let's say I have to index something, I have an indexing variable which takes value from 0, 1, 2, 3, something like that. So if you see syntax was for variable in iterable. Okay. So now this iterable I'll have to manipulate. Okay. So how to create this iterable? Probably many of you will hear it for the first time. So we use the range here. So range again a function. It will basically create an iterable over here. So if I say for I in range, okay, this range is a function. It takes three parameters. It takes the initial value, it takes, okay, it takes a final value or maybe a condition final value, and it takes a step size. Okay, this is initial value. Okay, this is my final value, and this is the step size. Internally, probably it also has been implemented because we are reading about C Python. So this again, this range has been implemented with loops itself. Okay, but when you code in Python, so what will happen is for I in range, so this will actually give an iterable. Okay, why is C fast? Because you see, for running a loop, it runs a loop within. Okay, because to get this is the function call. So if you see this function, so in this function it's running a loop because it's returning these variables. Let's see what this range function gives me as an output. Okay, first we will see this range function. Okay, going back to the VS Code and seeing the range function, what this range function does. Okay, let's say you have this range and you are writing from 0, 10, step size is 1, let's say, and we're collecting it in some variable a, let's say, and I want to print this a. Now if I see it, python py.test, you got a range. This is the range again. This again is a data type. It's a data type within, and it's a iterable. So this, if you see it over here, so maybe arrow is right, huh? So here what is returned is range 0 and 1. So again this was made a data type. So now if you just want to check the type, this is how you can check for the internals. And I sometimes I'm not sure what will get printed, but so print type of a. That's how you learn a thing. But this range is also an iterable. Now if you see, this is class range. Can you see? This is class range. This is class range over here. So range again is a data type within. So it is an iterable, but it is an iterable. You can iterate. There is a concept 0, 10 basically means it has 0, 1, 2, 3, 4, 5, 6 till 10. Okay. Let me test one more thing for my clarification also. So if I give the step size, if I give the step size 2, okay, now I want to print rather a. Okay, now I want to see what it is, what this returns. So you can see 0, 10, 2. It says the step size is 2. Okay. So just clear it. So again, this range is an iterable. Everybody with me so far? So this range over here that I wrote is an iterable. It is from a range class. It is an iterable. Basically, you can iterate through that. Okay. What I said is that if you see the internal implementation properly, it will be having a loop within. Okay. That's why Python is slow, because to just run a loop, you again are running a loop within a loop. Okay. Now I'll just maybe erase this range. So let's suppose we have this a. Keep it as it is. So this is iterable. So what I write, I'll say for I in a. So now you know that there is 0, 2, 4 until 10. Okay, for a in a, print I. Print I. So rather I'll just first show the simple example, which will start by one by one, which will just increment one by one. So if I just print it, you can see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, because this a is an iterable and we have an access to the iterable. When you see from the websites, they won't see this, they won't show you this syntax probably for variable iterable. It should be an iterable. Probably somewhere it might be there, but they'll start with this range. Okay. Now you know that this range is the iterable, and once you iterate through this, and you get the access to each element. So now coming back to this range. So what this range gives you is, so this range is something. This range is a function. Okay, or maybe we can call it a class. It's a class. This because it's a data type. So class is, this is initial value, and this is final value, and this is the step size. Okay, we have seen it also in strings when we were learning about slicing. So if you started from 0, if you let's suppose only give this, if you give range, say 10. So this 10 is only taken as final value. Initial value is by default 0, step size is by default 1. So this is by default 0, this is by default 1. Okay, and this final value you have to initialize it. Okay, if you just probably, it should throw an error if you do not give range any argument. Let's try that. Okay, testing the theories. So let's suppose I don't give any argument to this. Probably it, either it takes 0 or it should. If it does not throw an error, we'll see. It throws an error because you can see that a range expected at least one argument. Okay, I hope screen is not visible. Is it? Yeah, it's visible. You can see over here is. You can see over here that this range takes at least one argument. So you must give this final argument at least. So final, basically the final integer that you want. Okay. Closing VS Code. So I'm saying this range, they have initial value, by default it's 0. Final value you must give it, so mandatory I'll write it by star, and here this by default step size is also 1. Okay, so if I write range 10, this will be 0 to 10, basically 0 to 9, 10 elements. Okay, and if I give 0 and then I'll give final, I have this range, of, let's suppose 1, 5. So what will happen is it will include this 1, 1, 2, 3, 4, 1, 2, 3 and 4. It won't include this 5. So basically how you should think that this is number of elements if you want to see it that way. Okay, 5 is the end thing. If the step size is, let's suppose 1, then this is the number of elements. If you see this 1, 2, 3, 4 and 5, because 0 is not included, otherwise we would have also included 0. Okay, this is the end condition. So now if I write range 1, 5, 2, so what will happen is it will be 1, then it will directly jump 2 steps ahead. It will be 3, and now 5 is excluded, it will only give me 1 and 3. Okay, you must, and step size can be reverse also. You can put -1, a reverse step size. Okay, and you can have this start value, and you can have the end value. Basically rather they have start, end and step size. And you know this range function now, and it's an iterable, you can iterate it. This is an iterable, you can iterate through it, and that's how you got everything. You can get access to this. The syntax is for a variable in iterable. Okay, that's how we use it. Now we are using this range with range. Okay, now opening the VS Code to just check, show you some examples. Okay, just maybe I'll close this file. I'll create new file. Let's suppose code. The way to create like this, press Control N here, and press Control S, write test2.py. It's not visible, I know. Okay, so what I want to do is with the range, so I'll just paste some code over here. You can see this. So for I in range 0 to 10, step size 2, it will print 0, 2, 4, basically all even numbers. No, it's still running because we have to have test2.py. You can see 0, 2, 4, 6, 8. Okay, now you can have reverse indexing also. Let's suppose I'll start with 10, go till let's suppose 0, and have an index of -1, something like this. You can see 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We're going reverse. Okay, so I told you this range itself is it's a class. Okay, you can see the data type, and it's actually an iterable. It is clear so far? So that's end for today's session. If you have any questions, you can ask me. I'm stopping the recording.